Hello, I'm Raido Puust again, and in this brief video we take a first look into AutoCAD Civil 3D module called Autodesk River and Flood Analysis. Once installed, you find all its tools from the ribbon tab called River, and in this video we use AutoCAD Civil 3D 2017. Pay attention to that this module was available in previous versions. Right now you see the final finished project in where we present a flood map on top of our Civil 3D surface model, and in this video we do a step-by-step tutorial how to get here, or how to run your first HEC-RAS simulation inside AutoCAD Civil 3D. Before we start, it's maybe good to say something about this module in general. Autodesk River and Flood Analysis module enables users to carry out HEC-RAS calculations and modeling to analyze the hydraulics of water flow through natural rivers and other channels. You can do that directly within AutoCAD Civil 3D model. Using this module, you are able to create HEC-RAS cross-section cuttings much easier, and there are even some automated workflows that we can use and see in this video. You can carry out water surface analysis, floodplain mappings that are FEMA approved, and other related tasks, including HEC-RAS 3D model and reports. You're able to make sophisticated bridge and curvet analysis and automate the process designing and analyzing roadway crossings. By saying that, we now start from scratch, meaning that to carry out flood analysis, we do need to have some base data, including riverbed. I'm using InfraWorks 360 for that to generate that base data. Please do understand that depending on project stage, you may need to have some more exact data, but the workflow is the same, so nothing to worry about if you want to learn how to set up your first HEC-RAS model inside AutoCAD Civil 3D. If you are new to HEC-RAS model, then it's good to start from US Army Corps Engineers website, because there is also a free download. HEC-RAS is a free software package that can be used to create the same analysis as we see in AutoCAD Civil 3D, because AutoCAD Civil 3D is using the same software but inside AutoCAD Civil 3D user interface. If you want to test it only inside AutoCAD Civil 3D, you don't have to download HEC-RAS software itself. It is just enough to have AutoCAD Civil 3D with that module. But if you are willing to export your model from AutoCAD Civil 3D into HEC-RAS format, and you want to carry out some more analysis inside HEC-RAS product itself, then you can do it, and of course then you need to download it separately. We will have a brief look how we can do that. As I mentioned, we need some base data or surface data inside AutoCAD Civil 3D to start our flood analysis. I use InfraWorks 360, and I already have a project to where I want to concentrate. In here we see a river flowing from the right to the left to the sea, obviously, and city area at both sides of the river. So our main idea in this video is to analyze what could be a flooding area within different river flow rates, because flooding may occur due to rise of seawater level. In this video we only look at the river flow rate. It may due to snow melting or because some other factors. I will zoom a little bit, and I'm concentrating to the full area of the river, and if I'm satisfied enough, I can do a export to IMX file so that I can take that information into AutoCAD Civil 3D. My main interests are of course river centerline and surface model. I have carried out this export already. It is quite an easy step, so I minimize my InfraWorks 360 window and close my finished project. It is an empty Civil 3D drawing to where I'm starting to import my InfraWorks 360 model. For that I go to Insert tab and InfraWorks 360, open InfraWorks 360 model. I do navigate to the location from where I can find my IMX file. It's here, and I just hit open. Because this IMX file may include several information from InfraWorks like road centerlines and so on, and I don't want everything to be imported into AutoCAD Civil 3D, I can select about what I'm interested right now. So I select design objects and refine selection set. I do want to have existing ground surface. I scroll down a little bit. I don't want to have design roads, or let's say road centerlines, no intersections or no roundabouts, but I definitely want to have have river center lines. My main river is this one. Include other river center lines. Include bridges. It is not important at this time. I hit OK, and now I open my model. In a short time, we can see our model inside AutoCAD Civil 3D. I zoom in a little bit, and I can see my river center line and surface data. It's a thin surface and called as we selected it, existing ground. Let's have a quick look to our preliminary data. And as I mentioned before, for more exact studies, you may need to have more exact data, but the workflow is same. You have a surface model, and now you start to create a HEC-RAS model on top of it. If I do a quick profile using a polyline, and I just go over my river, then to analyze and quick profile, I select my polyline. I want to use my existing ground data. I hit OK and just include it here. I can basically see that I do have some riverbed, and I assume that it's my true riverbed. It is probably not as exact as it should be, but let's pretend that our data is exact, and we can continue with our flood analysis. I will zoom back to my surface area, and I will start to limit my area of interest. Basically, the main city area is located here and on the top side. I will use my river alignment during analysis, or let's say to create cross sections for my river. But I don't want to have it in full length. For example, for me it's not so important from here to the right. I just trim it out. At the moment, I will keep this line here because I want to see my analysis come up to the shoreline. This line is actually not needed because this is a different river and this is a smaller stream. So we are not paying attention to those right now. If I select my surface and do a right click and then object viewer, I can see that I do have a surface data, and I can easily follow that I do have some river bed inside it. That is the first step that you need to have. You need to have a surface data. It can be existing or proposed situation. It doesn't really matter. But from this step, we now move on. I close object viewer. Basically, I'm interested about left and right bank lines that are used as boundaries from where my manning coefficient is changing. I can do that by extracting contours from my surface model, but first I need to ensure that my contour lines are shown. I can easily check. Also, I can see it already, but I can easily recheck. If I right click, I pick a surface properties, and now surface style, I will edit it. And if I go to display tab, I can see major and minor contour lines. Those are available for me right now, so this is now okay. I hit cancel and cancel from here. If I select my surface, I can then go to my ribbon, thin surface and surface name, and from here on the surface tools, I can find command extract from surface. I hit this tool and picking extract objects. I want to extract major and minor contour lines and simply selecting all. I hit OK. By doing this, if I select my selection cycling to be on and click on some line again, I can see that now I'm able to pick my polyline or my thin surface. But I do need to do some editing with those polylines, meaning that in some places I do need to join it with the following polyline so that I can get just one left and right riverbank lines. Again, I assume that those lines that we have in here are true riverbank lines. If you are using more exact data, or you are using, for example, some GIS service, then you can create those lines manually by following a satellite image. I can easily draw a boundary, let's say approximately to here, and then I use a break command and just break it up so that I have different polylines at left and at right hand side. Do the same in here. Don't have to be exact. You can change or move that vertex later on. And if I don't need it, I will delete this line. I still have my surface surface valid, so nothing to worry about if you delete that line. Maybe it's easier if you are so-called digitizing riverbank lines that you use some other color value. For example, I use red here, maybe red in here. And now it's easier for me to see where I should continue my line or connect to another line so that I can get a one long polyline from start to finish. For example, in here, I do a change. I remove this vertex. I slightly move it away and then I reconnect it. I change the color here and I will definitely like to break it apart. So I use some polyline again, maybe around here. Using the break command, I break it, and this one I will break it. I don't need this line anymore, and select this polyline and using bilayer color again. Now I need to connect those two polylines, and I can use polyline edit, PE command, select one, you want to join, yes, select the other, and you should now have one polyline from start to finish that represent the river right bank line. I do a similar editing with my left hand river bank line. So in here I need to break it again. I need to break this one and use some different color again so that can be easily selected. I connect those polylines together and use a join command to join into one polyline. PE command again and select two other polylines. Hit enter, and to be sure just select it again and let's see if we have one continuous polyline on the left hand side. This is not a needed step if you want to manually create those river cross sections, but because inside AutoCAD Civil 3D we have automated tools, then this step will save our time later on. Some changes with my river centerline, because right now I can clearly see that it may not follow the real centerline, and I do that by adding or removing vertices. For example, maybe I want to add one more vertex here and then I'm able to shift it a little bit to the middle, and in that way I do some more editing. So if some more vertex is needed, I will add it as long as I'm reaching from one end to the other. Okay, maybe also one more here and maybe also one more here. I turn off my object snapping. Okay, shift it a little bit to here, add vertex. Okay, in here we see two different rivers are connecting with each other, so another river is coming into this one. I maybe shift it a little bit up, also shifting this vertex, maybe adding one more here, and some changes close to shoreline. I want to ensure that my line endings are at about same level, because we are creating cross sections based on 90-degree rule. We can imagine approximately to where this line should be placed, but those small changes can be made later on if we find out that something doesn't work out. Okay, this is now modified quite well, so we can move on, and I will save my drawing. Save. I don't need this polyline anymore, and we are now ready to continue with river and flood analysis module tools. So it means that I go to river tab and I will start to define my river cross sections. As you see, you have different tools available to create your cross sections. Before I start to create my cross sections, I will first define what data should be accounted for in terms of cross sections. And as I showed you before with this quick profile, we were using existing ground surface. That is a only surface object in our drawing right now. And if I go to create section and select section elevation data source, in here I'm seeing elevation layers. Basically, it's possible to use those extracted 3D polylines, but because they are aligned exactly with my surface data, I don't want to use those layers at all. So I select all and then hit ignore. Now I go to this elevation surface section, selecting my surface and hit use. Now I have told to my river module that I want to extract elevation data from my existing ground surface model. I hit OK. Now I'm ready to start to create sections, and I will use automated section cut tool. It saves a lot of time, but sometimes if you need to place those sections to exact locations, you may need to use some manual tools. creating those sections one by one. I select automated section cut, and now I can start from left to right. First of all, general river centerline. I will pick my polyline, and it's important to select those lines from the downstream end. So I click my centerline. I can then select cross-section cutting method. I use perpendicular. I can then select cross-section spacing, meaning that how often I would like to generate my cross-sections. I will use 100 right now, and then I can define my cross-section width. I will use a default value of 1000 meter, and this means now that I get my cross-sections from my center line up to 500 meters to each side. I don't want to use cut line right now. I'm skipping reference stationing, but I want to use bank stations optional. So in here, I'm now able to select those red lines that define my left and right bank line. So left bank line, I click pick and selecting my right polyline. Right bank line, I hit pick and selecting my right red polyline. I also want to use those same lines as my overbank flow lengths, but in general you're able to use some other lines that you can digitize on top of your surface. I can then define my cross-section ID labeling, for example starting cross-section ID from 100 and then with an increment 1. That is okay right now, so I hit OK. As you see, those cross-sections are now generated, those yellow lines, and those are placed with an increment of 100 meters. Once I do have my cross-sections, I can later on, of course, edit my cross-sections. For example, in here, I want to ensure that my river bank line is aligning with my true river bank line. Right now it is not, and it is due to that if I draw my cross-section perpendicularly, those two lines are connecting with each other a little bit further away. I can easily edit it. For example, if I select my cross-section line, I do a right-click, river, and section description. I can see that my right-hand side is way far away. So if I click on this cell, I can hit this little button, and now I'm able to select to where I want to place my intersection point. And I will use point at the same elevation as it is on the left hand side, but you are able to change it later on. So if I hit apply and OK, I'm seeing my cross-section view. It's easy enough to go back to your reach extents using those tools on your river tab. So zoom to reach extents, and now I'm seeing that my green line is more exactly following my red lines. In that way, you are able to make changes to all of your section lines. So it's up to you how exactly you would like to follow those lines. Go to the upstream end. I'm okay here, so I don't need to change it. Just a small tip that you are always able to edit your cross sections from a ribbon tab. For example, you can select section description, and then you see the same table as before, but you have to select now the exact cross sections that you want to edit. Instead of right-clicking it, you are able to select it from this dialog, and your cross-section view is changing. Basically, we want to define those Manning coefficients. I hit cancel and we'll go to input tab, section assign, and assign Manning's roughness. I hit this tool, and then I can include what will be my left overbank roughness, what will be my right overbank roughness. For example, 0.05 right overbank roughness, the same, and maybe my channel roughness will be like 0.35. You are able to input those values based on some reference tables. In here, you can select 3 dots and you will see a Manning's table. So from here, you are able to see and find out some specific value for your channel or river. I hit close. Once I'm satisfied with those results and want to apply to all my cross sections, I hit OK. My cross section views include those labels, but I go back to my reach extents. Next step will be to define our flows that we may have in our river. I use Create Reach Data and Flows tool, and I get a simple dialog flows. On the left hand side I can define my profile descriptions, meaning that what scenarios I would like to analyze. For example, I may name my first scenario as a minimum flow, the second one as my average flow, and my third one as my maximum flow. On the right hand side I can now define my flow values to that specific scenario. For example, my flow value for minimum flow scenario is as little as 3.5 cubic meters per second. I need to define downstream condition. If I know the exact value, I can input it, but if you don't, you can use some calculations. For example, I use critical depth. I then define my flow rate for average flow scenario, and this is 60 cubic meters per second, also using critical depth, and my maximum flow rate will be 900 cubic meters per second. Those values are usually calculated by stormwater engineer, or those values may be measured in the river. We can calculate those maximum flow rates based on some specific storm event that may happen, let's say, in 10 years or in 50 years time, or maybe in 100 years time. So there are several ways how you input those flow values, but typically you are interested about extreme conditions. I hit apply and OK, and basically I'm now ready to calculate my first flooding model inside AutoCAD Civil 3D. I'm using compute analysis button, and if everything is correct, I should see a message that my simulation has been finished, and I can see that there were 3 different scenarios that were calculated during my analysis. I hit close, and now I'm ready to present my results. First of all, it's possible to show those different water surface levels on your section views, but you have to export those results onto your section views. It's easy to do. I pick section results and add section results. I can then select which results I want to include. I include all 3 scenarios. I do have a possibility to colorize those different results. For example, if I talk about profile 1, I hit options and I can select that this will be a green line. I hit OK. I then select a second profile, again options, and maybe this one is cyan as it is. OK. And the third one, options, and this one will be, for example, red. Hit OK and OK again. Now OK, and if I zoom to my section views, I can select one specific section, hit OK. You can see your water levels on your section view, and you can see some notes down below. If I go back to Reach Extents, then I can show flood mapping, and for that I use Flood Map tool. I click on this and use Add Floodplain Map. I do have quite same options that I can select which profiles I want to use. I select again all those 3 scenarios. First one, options. I use some hatching and hatch options, pattern, solid pattern, OK, OK, and my color will be green, OK, and OK in here. My second profile, options, hatch and hatch options, pattern is already solid, OK, and color will be cyan, OK. And my third profile, options, color will be red, OK, OK. Down below, I can select what kind of information I want to show. I will show intersected edge of water right now and flood elevation contours. Later on, we come back and see some other options. I do have options right hand side. Typically, I want to include that erase previous results if there are any, those will be erased. I restrict mapping to model results and generating GIS coverages. I can hit options in here to select what kind of data will be included. Right now, cancel. I include a legend. I select this one and pick the location. Pick and maybe just down here. I now click OK, and depending on how many profiles I would like to see or what options I selected, it may take some time to generate our floodplain map. Hit OK. You have now your floodplain mapping, and of course, because our red area is largest one, it will cover all the other, but I'm able to just temporarily hide it away. Right click and isolate and hide selected object. Now I'm able to see other scenarios. So this was an average scenario. If my main interest is to show only the maximum event or the extreme event, I can easily delete all those minimum and average conditions or results using the same tool. I hit flood map again, add floodplain map, and now I'm deselecting those profiles 1 and 2. But I do want to make some changes with my profile 3, because as I mentioned before, my surface data may not be as exact as I would like, meaning that I may have some errors in my elevations. And because floodplain maps do depend heavily on our elevations, I can include some uncertainty bands with my floodplain map. If I select my profile 3, I can then activate flood uncertainty band and now hit options. In here, I define my fill type again, hatch, and hatch options as solid, OK, other or different color, for example blue. I hit OK, and now I'm ready to hit OK to calculate my new results. After calculation, I can see again that my red area is due to my flow rate of 900 cubic meters per second. But because I want to see the floodplain map due to errors in my elevation data, I have some blue area, meaning that my floodplain area in general is larger. In that way, we can easily account for uncertainties in our data. From here, I can move on and add some presentation-ready satellite images. There are different ways to do it. My geolocation tab and apply my map from here, because my model is in correct coordinates. I can easily turn my map on using map aerial or map road and so on options. If I do so, I should be able to see some context in terms of aerial image. From here now, it's reasonable to select your polylines that were extracted from your surface and just hide away those layers. Using Layer Manager, I close my C-topo minor and C-topo major lines. From here, I can grab this image so that I don't have to be online to show it, meaning that I can create easily presentations. But there are different ways to enrich your analysis in terms of context. Depending on services that are available at your location, your image quality may be simply higher. If I go back to geolocation and turn off my aerial image, map off, I use command map W space, turning it on, and then connecting to data source. Manage data content, connect to data. I use add WMS connection. I use predefined URL, and default version will be 1.10. I connect to it, no logins are needed, and then I can make it larger a little bit. I use satellite image and add it to my map. I close data connect and task pane. If I zoom in now to the location where my data is situated, I may see that I need to change the draw order so that my analyzed results will be on top of satellite image. I can easily do it at task pane again using draw order selection and just redefining in what order my view is generated, keeping my satellite image below my map base. I close task pane, and as I see, my image quality is much higher using WMS service. So you have to test different services that are available at your location. If I zoom in, the level of detail is getting higher. My river bank lines can be followed from this WMS service perhaps more exactly. So basically you can digitize your new left and right bank lines and do more exact studies. We will finish up our video with some other possibilities from river and flood analysis module in terms of calculation results. If I go back to my river tab, I can see that I do have output section, and in here results viewer. From here I can select, for example, section tables, and I do get a summary about my sections in table format. I can do some additional modifications applications in here, including some printouts or saving SAT data to different formats. I close this table form. I can generate output report and selecting maybe just one profile, set extreme condition, report options. I hit OK and I do get a simple report that basically looks the same as in HEC-RAS standalone product. I close it, and as a last step I can export my model into HEC-RAS standalone. I just save my project once again and I use export HEC-RAS project. I click on it, I choose or pick location to where I want to save my project file using the same name as my DWG. I save it and now I can open up HEC-RAS standalone product. Once again, you don't need to have it to work with Civil 3D alone, but if you want to do some additional studies in common environment, then you can install this standalone product. I can open up in HEC-RAS my exported project, open, select the folder from where it can be found, so River demo. I hit OK, and for example, everything you created in Civil 3D using some automated tools, all that data is available in here in HEC-RAS standalone product. If you edit geometric data, you see all your cross sections are here. You can edit this cross section and all your data is same as in Civil 3D. So I close my editor and HEC-RAS standalone product. Okay, that was it to give a overview about river and flood analysis module inside AutoCAD Civil 3D. And of course, if you found this video useful, please do subscribe to my channel and you get notification about my new workflow videos. Bye bye.